the way that the gold is deposited on the nickel, it's through a replacement process where each atom of gold replaces an atom of nickel. So then the more gold that it's added, the more nickel it's removed. And when that removal process happens, it starts to create phosphorus molecules. And that the more of that phosphorus that gets built up there, the weaker the connections, and phosphorus is not a solderable surface, which then makes that joint weaker
I see.
for mounting the components.
I believe we started getting identification of this issue from folks in the medical community that were seeing or experiencing parts of this on some of the medical devices that they were soldering to. And so that's where that kind of push came into our knowledge sphere. And we then were getting passed down on us specifications requiring it staying below that threshold, and they have different classifications of what that hypercorrosion can be based on the total thickness of that gold on top of the nickel. And so we backed off in our process that way, and then the spec came out and we made the wholesale change to adhere to the spec, and that's when we started seeing some challenges with legacy customer drawings that were calling out ranges outside of the spec.